Hello guys, good evening. Can you hear me? Okay, we'll wait a few minutes for others to join and then we'll start. Okay, so guys, yeah. So today we are going to start a new chapter, metallurgy. Okay, so like we'll finish this chapter today itself. Okay, we don't have much to study. One class, 4 hours is enough, for this topic. If you look at the importance, I did not check. Aditya, I'll see. Okay, yeah. Aditya just dropped me a hi. Okay, Aditya C
Yes, sir.
on WhatsApp. Yeah. Okay, so like if you see this particular chapter, I think from the board syllabus also they have removed for this year, right? And as far as competitive exam is concerned, this chapter is not that important, especially for JE. Okay, for other exams like BITSAT, CET, they ask few, theoretical questions on this. They are not any numericals you are going to get in this particular chapter. So it's basically theory. You have methods, process by which we can extract metal from its ore, correct? So metallurgy is all about extraction of metals like copper, zinc, iron, aluminium, right? How do we extract metals from its ore? What is the property of the ore of the given metal? And based on the property, we choose various processes. Okay. So what are those processes? Right. Based on property, how do we choose the processes for the extraction of a particular metal? That is what we are going to see. Okay. So basically, if you look at this, all this stuff, you need to know the properties. Based on the properties, we'll have the purification of metals. Correct. So if you look at these elements or metals that we have in earth crust, they're available in combined state, right? If you look at elements in earth crust, they occurs in or exist in combined state, correct? Element occurs or exist in combined state. So basically, all these elements, metals, whatever you say, okay, they reacts easily with oxygen, for example, you say they can react with moisture, they can react with other chemical elements also, and exist in the form of what? In the form of compounds. We haven't, no, D and F block we done. No, what is the last portion we have done? D and F block.
So we were just doing zinc sulfate then, sir.
Ah, right. So it's done. I think few compounds are there. Just one or two, three compounds are there. If you look at the chapter, there are so many compounds given. Okay. So most important one we have done. And I said last class that other compounds you can go through on your own. There's
Okay,
nothing much
yes.
left. Okay. So yes, that was my understanding. Hence, I'm starting this particular chapter. If you want, you have any doubt, we can do that later on. Let's continue with this. Yes, yes, yes. NCRT is more than enough that you can go through. So I think we are done with D and F block. There are so many compounds if you look at the books, right? But all those compounds are not important. Important one we have discussed. You need to focus on NCRT for these chapters. Okay, not more than that. Yeah, Vivek?
Yes, sir. Thanks.
Okay, yeah. So that is what I was talking about. Elements. So in this chapter, again, I'm repeating. In this chapter, we are going to study about the extraction process of metals. Correct. That's the basic thing we have. Only one particular thing is important for JE point of view. That is Ellingham diagram. Okay. Ellingham diagram is important for board also, but since this year you don't have this chapter in board syllabus, so that is also gone, right? But for JE point of view, Ellingham diagram, properties, what all information we can extract from Ellingham diagram, that you need to focus on. Okay, all other things are not that important for JE. Okay, so yes, so element occurs or exist in combined state. All these elements, like under different conditions, they may combine with oxygen, moisture, or other chemical reagents and occurs in combined state. Right. For example, you see non-metals mostly exist in the reduced form. Okay. So I'll write down here. Non-metal, for example, you see non-metals exist in reduced form. Okay, reduced form means what? For example, if I take the example of halogens, they exist in the form of X minus, Cl minus, Br minus, I minus, etc. Reduced form they exist in the form of halides. Okay, metals which we are going to focus on in this chapter, metals are no, they are reactive towards oxygen, so they generally exist in the form of oxides. Okay, so metals exist in the form of oxides. For example, you see, we have Al2O3, aluminum oxide, alumina we call it as, iron oxide is Fe2O3, etc. So our job is to extract these metals like aluminum from its oxide, iron from its oxide. It's not necessary that we'll always extract metals from its oxides only. Which compound we are going to choose for the extraction of metals, that depends upon several conditions we have for that. Like suppose you need to extract aluminium, correct? So we have aluminium ka different compounds, correct? So if you take one particular compound, yes, right, Venkat, right? If you take one particular compound, you need to think of the convenience of the process that we are going to use to extract the metal. So the process must be convenient and economical for the extraction of metal. There's no any point of extracting a metal and you are putting so much of money behind it, right? Because eventually you have to make profit out of it, correct? So we choose those compounds only from which we can extract metal conveniently and economically, right? So among all those compounds of one particular metal, those compounds that we choose for the extraction of metals, we call it as ores, right? And all these compounds, like I have written over here, the elements which occurs in combined state. So the compound that we have, those compounds we call it as minerals. Okay. So whatever the compounds we have for any given metal, all those compounds belongs to the category of mineral. Among those compounds, one particular compound that we use for the extraction of metal, we call it as ores. Correct? So all ores are minerals, but all minerals are not ores. Okay, I hope you understand it. The 2 points we have over here. Uh, we first of all, you write down the definition of minerals. Minerals. Write down compounds of metals which are compounds of metals which are naturally available, naturally available, naturally available in Earth's crust, in Earth's crust, and can be obtained by mining, can be obtained by mining, called minerals, right? Next definition we have, that is ore. Definition, write down. These are the minerals from which, these are the minerals from which a metal can be, a metal can be extracted, extracted economically, extracted economically and conveniently, conveniently are called ores. So basically, minimum input, maximum output. Okay, in the most excuse me, economical way. Correct. So one last point after this, you add all minerals are ores, but all ores are not minerals. Vice versa is not true. Done. Yeah. Okay. Example you see. Yeah. Example is, suppose FeS2. It is a compound of iron. We call it as iron pyrite. Like this, you will get many compounds over here in this chapter, for which you need to memorize the formula plus name. Okay, because not in JE, sometimes in NEET and sometimes in other, regional exams like BITSAT and others, they ask questions on this. Just a second. Yeah, FeS2, we have iron pyrites, is a mineral. Okay, we don't use iron pyrite for the extraction of iron, right? Is a mineral, not an ore. Why? Because FeS2, the extraction of iron, it requires high cost of production. Okay, so it is an ore, it is not a mineral. Okay, we have one more term over here which we call it as gang. Gang are what? Gang are basically the impurities. Okay, these are the impurities present in the ore. present in the ore. We call it as gang. So these are some basic definitions we have that you need to memorize. Not much important, by the way. Just you need to know that what is mineral, what is ore, what is the difference. Okay. So what we are going to do here next, we are going to understand the various processes that we use for the extraction of any metal. In general, we discuss. It's not like we are going to do one specific metal. Okay, that is what we are going to do. We'll do in the last one or two metals we'll do, but the process that we are going to use, whatever metal we have, more or less, we are going to have all those processes only that we are going to see next. Correct. So we'll discuss the process first. What is the overall process we have, and how do we extract in given steps? What are different methods we take for the separation of metals from impurities? Okay, based on the properties of the metal and impurities, right? We use one particular methods for the separation of what we say metal. Correct. So we'll discuss some general methods in different steps, and those methods only we will be using for the extraction of a given particular metal. One or two steps may be different here and there, but more or less the concept will be that only. But before going into the methods or the process we have for extraction of any metal, we'll see some compounds and its molecular formula. Like I said, you need to know some compounds and their molecular formula. I'll write down few compounds here. You also copy it down, and you have to memorize it. Okay, it is important. Like I said, not for JE but other exams, they ask these questions directly. Okay, so some examples of uh, compounds you write down here. Like the first one we have, heading you write down chemical formula. Chemical formula. These data I have taken from different books. NCRT also I have referred for this. So all those examples which are given in NCRT, that is also important here. So the first one is, you see, the first one is ginsite. Ginsite, you should know the molecular formula. Its molecular formula is ZnO. Correct. The second one is Fe2O3. Fe2O3, the name is, I'll write down the name first, wait. It is hematite. It is hematite, Fe2O3. Okay. Magnetite. Magnetite is Fe3O4. Okay. Next is pyrolusite. Pyrolusite mineral, you must be remembering this. We use this for the preparation of KMNO4, right? MnO2. Next is cassiterite. CASSETERITE. Cassiterite. It is SnO2. We also call it as tin stone. Tin stone. Copy this down. I'll go to the next page. Let me know once you're done. Okay. Yeah. Monoxides of uranium, that is, we call it as pitch blende. Formula is U3O8. Bauxite. Bauxite is Al2O3. dot 3H2O. Okay. Galena, they have asked many times this. Galena. Galena is lead sulfide, PBS. Cinnabar also they have asked in the exam. Cinnabar is sulfide of mercury, HGS. 1 second, Siddharth. You can copy this down. I'll go back again. Okay. Numbering here and there will not affect much. Okay. Just you copy this down. I'll go back after this. Okay. Okay. Cinnabar is HGS. Fool's gold. This also they have asked in the exam. Fool's gold. Generally, this kind of question there is CT bit Saturn. Fool's gold is iron pyrite, FeS2. Argentite is Ag2S. Like all these are sulfides basically. Okay. ZNS also they have asked many times. Zinc blend we call it as. Zinc blend is ZNS. Okay. Copper pyrite is CuFeS2. Copper pyrite. Chalcopyrite also we call it as. Copy this down. Chalcopyrite. Okay, Siddharth, copy this down. Done, Siddharth? Okay, finished? All of you? Done? Okay. Few more compounds we have here. The next one is Indian saltpeter. Is KNO3. Chili saltpeter is NaNO3. AgCl, like I'll write down the name first. Horn silver. Many times they have asked this question. Horn silver. Horn silver is AgCl. Okay. Cryolite. Cryolite is Na3AlF6. Cryolite. Okay. Fluorspar. That is CaF2. Sylvine. Sylvine also they have asked in the exam. Sylvine is KCl. Okay, magnesite, not much important, this one, but this is a known compound to you. It is MgCO3, magnesite. Okay, dolomite, important, this one, dolomite. Dolomite is CaCO3. It is an addition compound of calcium and magnesium carbonate. Siderite. Siderite is FeCO3. And the last one we have is calamine. Calamine also they have asked in the exam. Calamine is ZnCO3, zinc carbonate. So I've written so many. In all these compounds, you see, this is important, this is important. Like the one which they have asked many times. Okay, cryolite also they have asked, Hornsilver also they have asked. Okay, these two also they have asked here. So this last slide is the most important one. Done? Okay, so these are the few things that you need to memorize. Next is the one that is, for this chapter we have is to understand the process of extraction. Okay, to understand the process of extraction. This is what the entire chapter is all about. Okay, so like I said, we will first discuss the general process of extraction. What are the methods we have in this, involved in this, and based on the property of the impurities and metals, we use one of those methods for the extraction process. So overall, the the map of extraction is what you see. We have an ore first, right? So we have, first of all, we'll choose the ore. From this ore, we'll do the concentration of ore. And this concentration term has nothing to do with the concentration, morality and all. Concentration of ore means we also call it as ore dressing. Okay. So basically, we prepare ore for the further processes of extraction. Okay. That we call it as concentration of ore. So next step is the concentration of ore. Concentration of ore. We also call it as partly concentrated ore, because obviously in one step you cannot remove the entire impurities. Correct. So step by step we'll do, right? We use different reactions, we mix different compounds so that we can remove the impurities from that. Okay. The same process here, I'll just change the color and write down here. The same process we also call it as ore dressing. Or dressing. Once you are done with it, you will get what? You will get concentrated ore, right? From this step, second step, next you will get the concentrated ore. Correct? So this is the concentrated ore we have. You'll get the concentrated ore. With this concentrated ore, I'll write down steps also involved over here. We further get impure metal. Impure metal. Okay. And then we'll apply some methods into this. Then we'll get the pure metal in the last, which is our objective here. right? So after this, we'll get the pure metal. Okay. So basically, the method that we use here, we use different methods in the first step. Okay. Um, I cannot write down the entire process over here, but overall the thing is this only. We can use here in this step after taking ore, we can use flotation. We can use flotation method where we use the grinded ore will put into the solution and we mix it properly so that the froth forms, right, which we can take it out. Like it is, we use this method when we have the difference in density between the impurities and the ore. Don't write it down, just listen to me, because one by one we'll discuss all these steps. Okay, where I'll write down, I'll tell you that what is the condition we have to use this particular methods. Okay, so flotation is one of the method. Another method is hand picking. Suppose you have this sample, right? Let me just write it down. Where we have, suppose this is the actual metal particles we have present here, which obviously mix. It's not like it is separated. In this also we have mixing of metals, right? So this is the ore particles mixes with some impurities, and apart from this, there are others, impurities also present like this. Suppose which you can easily identify with the naked eye, right? Like this, suppose unwanted or impurities are present over here. Unwanted particles or impurities are present, which you can easily hand pick, right? We can look at it and you can remove it through hand only, right? Manually you can do this, right, by physical methods. So hand picking is also one of the process in the concentration of ore. Like all those impurities which you can see, observe, right? You can hand pick those particles. That is one part of concentration. Okay, so hand picking is one of the method. We have hydraulic wash also, gravity separation method we have over here, right? We have froth flotation also we have over here, right? We have electromagnetic separation when the metals are impure, are present over there, which contains magnetic properties, and impurities does not show any magnetic properties. So in that case we can use magnetic separation, which we also call it as electromagnetic separation, right? All these processes we can use. Once the concentrated ore you get, okay, after concentration is done, concentrated ore you get, then we use to reduce, because usually we get here oxides of metals, which we can reduce and we can remove oxygen and we'll get impure metals over here, which we can do for purification. So what are the different steps we have that we are going to discuss now? Always keep that in mind. Concentration of ore has nothing to do with the concentration term that we have done so far, right? It only and only means that we need to prepare ore for the further processes, right? Which we call it as concentrated ore. Correct? So this is the flow map of extraction processes. Now we are going to discuss one by one what are these steps, what are the processes involved in these steps, and what is the required property for metal and impurities we have. Okay. So first step you write down. The first step is grinding and pulverizing. Grinding and pulverizing. I'll tell you the method what we have, all these methods. See, what happens in this, the ore that we get from earth crust, generally these ores are present in the form of big lumps. Okay, because it is it is present in the combined state, no? So it is possible that the ores are present in a big lump. Size is big over there. Okay, so what we do, first of all, we take all these ore particles, the lumps that we have, and we break down this into small pieces. First of all, right, we break down this into small pieces, right, and this we use in crushers or grinders. So this process we call it as grinding process. Understood? To break down the ores which is present as a big lump into small pieces is grinding, which we usually done in crusher or grinders. Okay, what is pulverizing? Pulverizing is even one step, further you need to go. Not small pieces, you need to convert this into powder form, right? Fine powder form, which we used to do in ball mill. Okay, ball mill is the name of the device, or we can say the machine that we use for the process of pulverizing. Okay, if you study mechanical or chemical engineering, you'll be dealing with all these machines in the lab in your engineering college, right? Like I said, ball mill, you have crushers, you have all these civil engineering also, we have these kind of application. So grinding, write down in this quickly, right? Ores obtained from the earth crust. I'll also write down 1 second. From the earth crust is generally occur in the form of big lumps. Next line, grinding is the process. Grinding is the process we use to we use to is the process we use to convert, or not convert you don't write, used to break down break down the ores into small pieces, and for this what we use grinders, we use crushers. The machine that we use here is grinders. We can use crushers for this process. Okay, grinders or crushers, not important, this you don't have to memorize. Okay, next line, write down, in pulverizing, write down next, in in pulverizing, the small pieces are reduced to fine powder are reduced to fine powder with the help of ball mill. Ball mill, like I said, again, a device we have, the machine that we use for reduce the size of the particles. So first of all, we take the ores, the big lump, then we break this down into small pieces or fine powder. This is what we have in grinding and pulverizing. The first step is this. See, any process, Venkat, if you see any process that is required, first of all, small pieces, small size will have large surface area, right? So we can have better interaction with other reagents, right? If some reaction is to take place, or if you want to prepare a solution, right? Suppose froth flotation process you have, right? Where that we use when we have difference in density between the metal and the impurities. So what happens when you mix this powder into the solution, right? It forms froth. We continuously mix this, so it forms froth, right? So heavier density substance that settles down, and lighter densities that will be at the surface with the froth, which we can easily filter out. Are you getting my point?
Got it,
So
sir.
if you
Okay.
don't break down into small pieces, you won't be able to prepare the solution out of it. It won't mix properly.
Oh, okay, sir. Okay. For better reaction happening.
Yes, better reaction you can say, or to prepare a solution for other processes, for the steps, you need to reduce the size of the ore particles that you are getting.
Oh, okay, sir.
Correct. So
Yes,
this is
sir.
the first step, that is grinding and pulverizing. One second, Shashank. Grinding with the help of it is the ball mill. Ball mill is the machine that we use. Reduce to the fine powder with the help of the ball mill. Ball mill is the machine. Correct. Now, this is the first step which is done, grinding and pulverizing. We are done with it. Next step is the concentration of ore. Concentration of ore, which we also call it as ore dressing. So it's kind of will dress up ore for the further processes, right? Correct. So it's like uh, in this process, what happens? All those impurities which we can remove easily without any chemical reactions, like I took the example few minutes back of hand picking, those kind of process takes place into this. Okay. Or some physical processes, like we have hydraulic washing, okay, gravity, which is also known as gravity separation method, okay, we use in this process. So concentration of ore, write down the metallic ores. I'll also write down, otherwise you'll get confused. Copy this down. The metallic ores obtained from earth crust are often mixed with non-metallic non-metallic and rocky materials, ROCKY, and rocky materials. Rocky materials such as we have sand, clay, etc. So we'll mix all this sand, clay, right? Limestone. So metallic ores obtained from earth crust are often mixed with non-metallic and rocky materials, that is sand, clay, limestone, etc. Right? Correct. We mix this and then we'll allow this mixture with ore and this, the the non-metallic and rocky materials that we add. We allow this to pass through a gravity separation process. We have hydraulic classifier there, as machine we call it a hydraulic classifier, from which we allow this mixture to pass through, and then we'll see what happens in this. I'll show you the diagram also over here. But in this first 2 points again you write down here. We know the impurities present in the metallic ores are called gangue. We also call it as matrix. Okay, gangue or matrix are the same thing. Both are impurities. I'll just write down here: gangue and matrix. So both are impurities. Gangue or matrix, both are impurities. Okay. Write down the concentrated ore which is also relatively purified. The concentrated ore is called concentrate. Okay, the concentrated ore is called concentrate. Right, this process, concentration of ore, this process we also call it as benefaction process. Just we have different names. Purpose is same: BENEFACTION, benefaction process. Okay, concentration of ore is called benefaction process. Now what we do for the concentration of ore, what we do for the benefaction of processes, correct? A benefaction process. The first method, like I said, under this concentration, we can do hand picking. Okay, I'm not dictating you anything into this. You already understood what is the meaning of hand picking we have. So we can do hand picking. We can also do a hydraulic washing. Hydraulic washing, right? Which is nothing but the gravity separation method. Gravity separation method. Copy this down.
One second, sir.
Okay. So hydraulic washing or gravity separation methods, when we use, what is the condition we have to use this method? Okay. So we'll use this method when there is a difference in specific gravity. Condition is what? The condition is we have difference in specific gravity between gangue and ore. We must have difference in specific gravity between the gangue and ore. If you have difference in these two things, gangue and ore, then we can use this method, that is hydraulic washing or gravity separation method, for the concentration of ore. Okay, so based on the property we use this. Copy this down. Okay. Now, under this hydraulic washing or gravity separation, we also have different methods again. Okay. So under this, you write down we have two processes, two methods we have. So first one you write down A, that is Wilfley table method. Wilfley table method. Correct. Now I'll show you the diagram of it, the picture, how it we use this particular thing. See this. This is the Wilfley table. Okay. So the powdered ore that you have, concentrated ore, see, you will understand the process easily here. These are the plates, you can say tray we have, on which we'll put this powdered ore over here. We have an inlet of water pipe which sprinkles over here on this tray, and then it comes down onto this table. This table. This is the vibrating table we have. We have some arrangement so that we can shake or vibrate this table continuously. It continuously keeps on vibrating. Okay. So what happens? The concentrated ore, the ore that we have, since we have difference in specific gravity, so all the concentrated ore they will shift towards the right, right of the table, or our left towards this side, and slowly it comes down from here to this side, and it will accumulate somewhere over here, and the gang or the impurities, it will come along with the water and it falls down over here. This is what the gang. And there are the slits we have. Slits we use to separate the you know the ore and the impurities present into this metals, and the impurities present into it. So whatever compounds, elements in which there is a difference in gravity, that will be separated by this method like this. Okay, you understood? So I'm not going to dictate you the theory in this. I hope you can understand with the figure how this process we use. Correct? Just a second, I'm coming. I'll take some water. 1 second. Yeah, 1 second, guys. Yeah, so this is Wilfley table method. We are doing this under concentration of ore. Okay, keep that in mind. Under concentration of ore, we have hydraulic washing, gravity separation method, under which we are doing this Wilfley table method. We have second method in this. Okay, both we can use when we have difference in specific gravity. On this particular information, they ask question in the exam sometimes. Okay, so if there is difference in gravity of specific gravity of um, of gang and metal we have, then which method we'll use. So name you just keep in mind. Another one is hydraulic classifier method. Okay, the B is hydraulic classifier method. Okay, hydraulic classifier method. Look at this, diagram. Hydraulic classifier is this. Try to understand the working. That is it. You don't. If you understand this, obviously in board the chapter is not there, or JEE may, and in other exam they won't ask you to write down the entire process how it happens. Okay, so these things are not important as far as the exam is concerned. Okay, so what we do here, we have a hopper, correct, from which we put the powdered ore into this entire system, correct, and from the bottom we there's an inlet of water here. We produce water from this, high force of water will be there. So here it will get mixed, suspension forms over here, suspension of ore. Okay, and we keep on blowing water into this, right? So slowly the metal particles, right, the concentrated ore, since it has higher density, it will settle down slowly, comes back into this container, and we collect it from this outlet. The gangue particles, which are what? Lighter, because we have difference in gravity, specific gravity. So it will be on the top mostly. So some part of it will come out from this outlet, which is the gangue particle we have. Okay, understood this? So this is the conical reservoir fitted with a hopper, right? It is a hopper. Conical reservoir is this, fitted with a hopper. We used to, when, if like, there's no point of discussing all these things because you are not going to get this in the school exam. But yes, the method is this only. Understood? So working, you just keep in mind how it works. If they frame some questions in the exam, any exam, competitive exam, then you can answer it properly. Okay. Condition is same. Difference in specific gravity will be there. The lighter gangue particles are carried away by the current of water, and heavier ore particles collect at the apex of the cone, the term that we use. Okay. Apex of the cone, the term that we use. Gangue particles are lighter, will collect it from the top, from here. Okay. Okay. One more thing, based on the design of this vessel, the classifier that you have, it is in the conical shape. Here you see, it is a conical shape that you have. Obviously, the bottom is not circular, but with this narrow part that we have here, what it does actually, it reduces the velocity of water. The water that you are pushing in, the high current of water from the bottom. So because of this narrow portion of the tube that we have, the velocity of the water decreases, and because of that, the metal particle which is here, which is heavier, right, it does not carry away. If the velocity is very high, it is possible that it will push the metal particles also in upward direction. But two things, because of this narrow part over here, the velocity of water decreases, right, and the metal particles which is already heavier because of difference in specific gravity, So this reduce in velocity of water plus the heavier metal particles, both both, what we can say, the metal particles that you have, it slowly settles down and comes over here. But this current is sufficient enough to blow this, the lighter gang particles that we have, which first of all comes over here and we accumulate from this. So that is what the construction part that we have. Why we have this conical shape? Because it reduces the current of water and helps in settling down settlement of the metal particles over here in this tank. Correct. This is the purpose we have over here. So this is the uh, you know two methods we have in hydraulic washing or gravity separation method. All these things again we are discussing under concentration of ore. The next method we have in concentration of ore, the third method is, write down all of you, the third method is electromagnetic separation method. Electromagnetic separation method. I'll first show you the diagram for this, and then we'll see the important points in this. We'll write it down. Okay, electromagnetic separation. With diagram itself, you understand that what kind of property is required for this kind of processes. Okay, so electromagnetic separation, you see this. Okay, so we have a roller over here and a hopper. Right, just above the roller, we have a hopper, and this is the belt we have. This is the magnetic roller, and we have a belt over here. Correct. The finely, powdered ore, we put this into this hopper, and this roller is continuously moving. Like it is moving in this direction. It is moving in this direction. So obviously, the ore particles which comes over here, it starts traveling like this, and it goes till here. The one which is, which is which has the magnetic properties, right? It will be in touch with the roller for a longer period of time, and it will fall somewhere here, right? All those, non-magnetic particles, it will lose the contact somewhere over here because it is rolling like this, right? It will lose the contact somewhere over here, and since the particle has a tangential velocity over here, so it will fall down somewhere here. Means you'll get a two different, points where the magnetic particles and non-magnetic particles will come, and hence we can separate the two here. Correct. So obviously this kind of separation method we use when there is difference in the magnetic property of the metal and the impurities which is present. Correct. Easier one, you can understand this carefully. Just few points you write down here. This method is based on this method is based on this method is based on magnetic and non-magnetic properties of ore, magnetic and non-magnetic properties of ore, and the gangue respectively. Magnetic and non-magnetic property of ore and gangue respectively. So ore is magnetic over here. You see, the magnetic particle is the ore. This is ore. Wait. This is ore, and this one is gangue. So like this, the gangue and the ore particles are separated by electromagnetic separation method. Okay. One last point you write down here. This method can be used to separate. This method can be used to separate chromite ore. Chromite ore is this, used to separate chromite ore, that is FeCrO2, chromite ore from silicon impurities, like siliceous, we also call it as, from siliceous impurities. Okay, so this is the third step we have under, third method we have under concentration of ore, electromagnetic separation. Okay, I have written it twice, magnetic over here. It is electromagnetic separation method. Okay, next method we have in this, in concentration of ore, the fourth one you write down. The fourth one we have is froth flotation method. Froth flotation. Froth flotation. Write down this first. This method is used, or this method is based on different wetting characteristics, wetting characteristics of ore, and gangue by oil and water. Different wetting characteristics we have by oil and water. Write down, ore is mainly wetted by oil. Ore is mainly wetted by oil, and gangue is mainly wetted by water. Okay, next line. This method is used for the separation of sulfide ores mainly. I'll write down here. Sulfide ores. For example, we can have PBS. What is the name of this sulfide? I've given it now. CuFeS2. Copper pyrite. Okay. ZnS is zinc blende. PBS is galena. Okay, must remember this name, important. This is galena. This is zinc blende. This is copper pyrite. Okay, must remember this. Okay. Mainly for sulfide ores. This information, they have asked question in the exam. Okay, froth flotation we use for sulfide ores mainly. Okay, so what we do in this process, write down a suspension of a suspension of finely powdered ore with water is made right, a suspension of finely powdered ore with water is made. This is called slurry. Okay, so in just in notation I'll write down, we have that finely powdered ore, we add water in it, and this suspension or the mixture that we have, we call it as slurry. SLURRY, slurry. In this slurry we also add some what we say, some froth, um, some stabilizers we add into this. Okay, so in this slurry we add various stabilizers which we call it as additives, right? So in this one, I'll just in notation I'll write down like this. In this slurry we add froth stabilizers which helps in the forming of froth stabilizers. We also add some amount of collectors in this slurry. Collectors, one second. Some amount of collectors in this slurry. So froth stabilizers, what all compounds we use for this? This one is important. This you must keep in mind. For stabilizing froth, we use compounds like aniline, we use cresol, etc. as froth stabilizers. Important, right? Collectors, mainly we use the salt of ethyl xanthate. One example is sodium ethyl xanthate. Sodium ethyl xanthate we use as collectors. The formula you see for sodium ethyl xanthate, we have this. Uh, Sodium ethyl xanthate. We have CH3, CH2, it is ethyl. O, C double bond S, instead of O we have S here. S minus Na plus. This is sodium ethyl xanthate. I'll show you the diagram also for this, the picture that we have. Right, so what we use as the froth stabilizers, you also copy down like this only, okay, in notation, because if you're going to write down line by line, it will take a lot of time. Froth stabilizers is this. We use an example, aniline and cresol we have. Apart from this, in order to form froth, okay, in a good amount of froth in order to form, we also add some oil into this, which we call it as pine oil. Okay, so we add, which we call it as frothing agents, okay, which can form froth. Okay, so it is a frothing agent we have. Mainly we use pine oil for this purpose. We don't have much example, only this much you need to memorize. So pine oil we add in order to form good amount of froth. To stabilize froth, we add aniline, cresol, and we use some collector, that is sodium ethyl xanthate. Fatty acids also we can use as collectors. Okay, so this collectors that we have, it it enhance the non-weighting ability of mineral particles. In presence of collector, characters, wetting ability decreases for mineral particles. Correct? So this is the few things we add into this. One small point again you write down. Write down in this suspension, one mode additive, one mode additive additive which is known as activators or depressant. Two terms we have here. I'll write down here. We can use activators or depressant. Activator or depressant is added right? Activator or depressant is added in order to use this method for non-sulfide ore also. Right? So activator is what? Activator is the compound which improves the floating characteristics, and is opposite of activator is depressant. Okay, activators improves the floating characteristics of ore. Improves the floating characteristics of ore. And the one which reduces the floating characteristics is depressant. Reduces the floating characteristics. Depressant. Okay. Example of activator, one example we have, write down. It is lead sulfate, PbSO4. Lead sulfate. Here we have NaCN, KCN, NaCN, KCN we can write. Okay, look at the diagram for this, the figure that we have. We have froth flotation, this. Okay, so we have this pedal here, which we can rotate in order to form the froth. Because everything, if you mix simple, when in water, if you add detergent, right, you have to mix it properly so that the froth forms, correct? Same thing we have here. We have an arrangement of mixing the mixture over here. Paddle we rotate. This is the blade we have, and hence the mixture, mix properly and forms froth. If froth is not forming, we'll add pine oil in order to get more amount of froth, right? To serve the purpose, right? So ore, we have an inlet over here to put ore into this and oil, and then we'll mix it, will forms ore, will forms this froth, which we can take it out or filter it out. Okay, air also we mix over from this point. We have an arrangement of blow air also into this mixture in order to form froth again. Okay, the same purpose we have here. Mineral froth, we can filter it out from this and we'll get the concentrated ore over here. This is the arrangement of froth flotation. Okay, so this method we have. Till now we discussed this under concentration of ore. So we discussed hand picking, we discussed hydraulic washing. In that we discussed two methods, which is Wilfley table method and hydraulic classifier. Okay, these two methods we discussed. And then the third method we discuss in this, electromagnetic separation, magnetic and non-magnetic property. We have that roller wala example, you must have seen that. And then the fourth one we have, that is froth flotation process. So four different methods we use for the concentration of ore, right? Now, when the concentration is done, concentration of ore is done, you get the concentrated ore. Then we have the next method, which we call it as leaching. One second. Okay. So once we get the concentrated ore, we have the next step for the purification, and that is the third term we have, the third step we have, that is leaching. Leaching, we also call it as hydrometallurgy. Hydrometallurgy or leaching, both are the same thing. Okay. Write down, it involves, I'll write down, wait. In leaching, write down, it involves the treatment of it involves the treatment of finely powdered ore finely powdered ore with a suitable reagent with a suitable reagent like acid base, any reagent we can use. We can use acid base, any other chemical reagent we can use. Write down, acid we can use for this purpose, base or other reagents, chemical reagents we can use for this purpose. Okay, and we choose this reagent in such a way that this reagent can dissolve ore but not the gangue or impurities. Okay, so it involves the treatment of finely powdered ore with a suitable reagent which can dissolve um, what, ore but not the gangue. This is the condition we have. Okay, write down the metal. The metal can be obtained after this. When we dissolve this reagent, we'll get the salt of metal, from which it can be obtained by different methods like electrolysis and other thing, right? The metal can obtain from its salt by electrolysis. Okay, I will give you one example here for leaching method. Only one example we'll discuss. Like suppose we are having the leaching of bauxite ore. Okay, bauxite ore. We call it as Bayer's process. This name is also important. Okay, Bayer's process. So in bauxite ore, first of all, what happens, you have to keep this in mind, that pure alumina obtained from the bauxite ore, right? In Bayer's process, pure alumina, that is Al2O3, obtained from the bauxite ore. Okay, pure alumina obtained from the bauxite ore. Okay, generally what happens in bauxite, the impurities present are, we have iron oxide like Fe2O3. These are the impurities present in bauxite. We have silica, SiO2, the impurities present, and titanium oxide, TiO2. Now, these are the facts. You cannot do anything into it. Like what impurities are present that you have to memorize. Okay. So in bauxites, all these impurities we have. Right. Now, this solution is mixed with the NaOH solution. 40% NaOH solution we mix into this. That is the base we are using. Suitable reagent, reagent is NaOH over here. Right? Now this NaOH, when added into this, so Al2O3 dissolves and convert into sodium meta-aluminate. That is the complex compound of aluminium. I'll write down the formula here. And other impurities are left behind. Right. So first of all, this NaOH, I'll write down the reaction here. We have the solution of Al2O3, the bauxite ore, and all those impurities present into this. When you are added with, you add this NaOH solution into this. This is solid. This is aqueous. Right. And obviously water we have here. So it converts into 2Na ALOH, 2Na ALOH4 aqueous. This is the product we get, right? Which in this is sodium meta-aluminate. Sodium meta-aluminate, which further on electrolysis, it converts into the next reaction we have Al2O3 solid plus the base we have OH minus in presence of H2O. This is the ionic form. I am writing it down. This is the molecular form. Ionic reaction is this, which is ALOH4 minus. Any one you can write. Okay, aqueous.
Sir, could you please go back to the previous slide?
Yeah. Okay, I'll go back.
After
We'll
this,
continue this. Sorry?
After this, sir. After this.
Okay. So we get this, right? Sodium meta-aluminate. Now this solution of sodium meta-aluminate is filtered, and the filter is cooled down, and at a certain pH, right, it is neutralized with carbon dioxide and aluminium hydroxide precipitated out here. Okay, this aluminum hydroxide, if I write down the reaction here, AlOH4 negative charge in is diluted with CO2, it converts into AlOH3. So CO2 is circulated here, right? It does not take part in the reaction. OH minus ion forms. Okay. And then this AlOH whole thrice, we heat this at high temperature, more than 1000, around 1500 Kelvin. Then it converts into solid alumina, Al2O3 solid, and H2O goes out in this reaction. So this is the leaching process we have. We add base, we get the salt of it. This salt, it is circulated with carbon dioxide, forms hydroxide here, AlOH whole thrice, which on heating converts into alumina. Similarly, we can have extraction of copper and other things also, but everything is, we don't have to do all this. Even this one is also not that important. Sometimes they have asked questions on alumina, that's why I have taken this example. Okay, I'll go back, just copy this down.
Done, sir. Thank you, sir.
Yeah. Okay, so we have done this concentration is done, and then we have leaching. Okay, when leaching is done, so in leaching we mainly we get oxides of metal. You see, we are getting alumina, oxides of metal. Now from this metal oxides, you need to take metal, you need to extract metal. So what we do, you have to remove oxygen from this, correct? So next step is the reduction of the concentrated ore. After leaching, we'll do the reduction. And reduction also we can do in two different way. Okay, both we'll discuss over here. So next step, after leaching, we have calcination. Calcination is, leaching we have done. After this thing, um, concentration of ore, we have leaching. After leaching, we have reduction of the concentrated ore. Reduction of concentrated ore. Okay, write down. Metals are usually present metals are usually present as hydroxides, means you have metal hydroxides, or you have carbonates, carbonates or sulfides, mainly sulfides, etc. Okay, Okay. So what we do, if all these hydroxides, carbonates, sulfides we have, so first we need to convert this hydroxide, sulfides and carbonates into oxides, right? So from metal hydroxide, we convert this into metal oxide. Metal carbonates converts into metal oxides. Metal sulfides converts into metal oxides. Why? Because we need to extract metal. So it is always easier to extract metal from metal oxides, right? Than all other compounds due to the thermodynamic reason. Okay, it is easily like feasibility of the reaction is easier in comparison to the other carbonates, sulfides, or hydroxides that we have. Correct. So one point you add in the last over here. Um, write down to extract metal from its compounds. Compounds means what? I'm not giving you all the three words. Compounds means hydroxides, carbonates, and sulfides. Okay. To extract metal from its compounds, the compound first converted into the metal oxides. Okay, so these metal compounds are converted into metal oxides because extraction of metal extraction of metal is easier from is relatively easier, right now. Extraction of metal is relatively easier from its oxides due to thermodynamic reason. Now, how do we convert metal into metal oxide? Okay, all these hydroxides, carbonates, sulfides we have. How do you convert this into oxide? So for that we have two methods. One is, we'll discuss under this. One is calcination. The first method in this, A, we have calcination. Write down, it is the process in which the ore is heated strongly. It is the process in which the ore is heated strongly is heated strongly in absence or limited supply of air. Important this point is, okay? Ore is heated strongly in absence or limited supply of air. That is calcination. Okay, they've asked question on this information. Okay, limited supply of air. At a temperature, at a temperature comma, lower than the melting point of the metal. Means the temperature should not be more than the melting point, because in that case the metal also will get melt, right? So temperature must be lower than the melting point and will heat strongly. okay, in absence or limited supply of air. So for example, you see this reaction, if you have this compound, hydroxide of iron, FeOH whole thrice. When you heat this, you will get Fe2O3, oxide of metal, and H2O will go out. How much? 3H2. Right? Hydrated ore, if you have, so for example, you see bauxite or Al2O3 dot 2H2O. We again heat this strongly. It converts into Al2O3 and H2O. Okay. If you have carbonates like CaCO3, we get CaO plus CO2. Calcium oxide, we get CO2. CaO we can also obtain from dolomite. CaCO3 dot MgCO3. Important this reaction is. When you heat this, you'll get CaO plus MgO, magnesium oxide, and 2 molecules of CO2 will go. So when you heat this in absence of air, we'll get the oxide of metal. So calcination is this. Okay. Now, the next second process in this reduction of concentrated ore, one way is calcination, other one is roasting. Other one is roasting. In this, the ore is heated strongly. Is heated strongly in presence of air. So previous one, absence. This one is presence of air. Again, at a temperature below the melting point. Excuse me. Done. So in this method, what happens, you see, all the sulfide ore will be converted into the oxide of metal. Okay, and that is what the purpose we have. So the reaction is, suppose we have HGS. This is the reaction we have. Cu2S plus O2 gives Cu2O 2SO2. ZNS plus balanced reaction, I'll write down. 3O2 gives 2SO2. By this method, we can also remove, write down, by this method, we can also remove, I'll write down, wait. we can also remove non-metallic impurities. Non-metallic impurities like arsenic, antimony, sulfur, phosphorus, etc. All these non-metallic impurities we can remove. So how it happens, all these non-metallic impurities converts into oxide and escapes, volatile gas it forms. So look at this reaction, 4As arsenic plus 3O2, it forms 2As2O3, volatile gas, it escapes into the atmosphere. Sulfur and oxygen forms SO2, escapes in the atmosphere. Okay, phosphorus O2 converts into P4O10, escapes in the atmosphere. One last point, it can also remove water from hydrated ores. These are the uses we have for this method, that is roasting. Done.